to you. Today I'll be telling about logistic regression. Okay, so first I'll tell about the proof and then I'll show you one small example. Okay, so logistic regression is a classification algorithm. Okay, it is used to predict the binary outcome. So it can be 1 or 0, yes or no, true or false from a given set of independent variables. So this is logistic regression. Okay, so I'll tell you about the proof of that. Okay, so I have taken this proof from our website. So here they're taking a sample of 1,000 customers and they're trying to predict whether a particular customer will read a particular magazine or not. Okay, so here age they have taken as the independent variable, and then probability P and probability of failure is 1 minus P. So P will always be positive. Okay, so being P always positive, they have taken the exponent of this one. Okay, this equation. Okay, that will e raised to beta 0 plus beta into age. So that this is nothing but p equal to e raised to y. Okay, so now to make the probability less than 1. Okay, so what you can do, you can just add to the denominator should be greater than the numerator. So for that you are adding 1 plus that same number. So it will become p equal to e raised to y divided by 1 plus e raised to y. Okay, this is what done here. Exponent of beta 0 plus beta into age divided by exponent of beta 0 plus beta age plus 1, so that p will be less than 1. Okay, for making that. Okay, so finally it has become this one. It has become p equal to e raised to y by 1 plus e raised to y. So this has become. Okay, so this is how you calculate the p. Okay, clear? And then what will be 1 minus p? Q will be q equal to 1 minus p equal to 1 minus this thing. That you can, I'll just show you that. So this is what. Okay, I'll just, so here p equal to e raised to y by 1 plus e raised to y. This you got. Okay, this you got. So what will be 1 minus p? 1 minus p will be 1 minus e raised to y by 1 plus e raised to y. Okay, and then you have to do the subtraction. So here 1 plus e raised to y minus e raised to y by 1 plus e raised to y. Okay, this will cut. So e raised to y and e raised to y get cuts. So 1 minus p will be 1 by 1 plus e raised to y. Okay, so what will be p by 1 minus p? So equation number 1 divided by equation number 2. So this will be e raised to y by 1 plus e raised to y by 1 plus e raised to y. So this is the basic equation. P by 1 minus p equal to e raised to y. Okay, so this is what. Okay, p by 1 minus p equal to e raised to y. So this is the our main equation. So this is known as odd ratio and all. Okay, that we'll come to that later. Okay, so p by 1 minus p equal to e raised to y. So I think you have understood till that. So okay, so you get p by 1 minus p equal to e raised to y. So this is the most important thing here, this one. Okay, log of, so this is how the classification is done. So I will just tell that also. P by 1 minus p equal to e raised to y. Okay, So we are taking log on the both sides. So log of p by 1 minus p equal to y. Okay. So this is from this they are doing the classification. How? Suppose p equal to 0.5. Okay. So what will happen? 0.5 divided by 1 minus 0.5, that will be 0.5 divided by 0.5. So log of 1 will be 0. Okay. So log of 1 is 0. Okay. Because anything raised to 0, 10 raised to 0 or e raised to 0, everything equal to 1. Okay. That is why log of 1 will be 0. Okay. So let us try it. Okay. Log of 1 will be 0. Suppose our probability is 6. P is 6. Okay. So it will be 0.6 divided by 0.4. Okay. What will be the answer? You will get one positive value. Okay. 0.17 something. Okay. So suppose, so this is a positive value, plus value. Okay. Suppose your p value is 0.4. So it will be 0.4 divided by 1 minus 0.4, that will be 0.6. Okay. What will be the value? It will be negative. So this is how they will do the classification. Suppose your p value is 0.6, then they will take it as success based on the positive value. Suppose your p value is less than 0.5, then the log value will become negative. So this is the basic thing. So I will just give an example for you. So I think I have explained here. So log of p by 1 minus p is the link function. So it just we are applying y equal to, we are substituting that p by 1 minus p is the odd ratio. Whenever the log of odd ratio is found to be positive, the probability of success is always more than 50%. So let us do one small example and see. Okay. So I am going to do a small example. Okay, and then let us see how we are understanding it. Okay. So how many minutes it has gone? Yeah, only 8 minutes. Okay. So I'm going to clear everything here. Okay, and clear the plots also. So there is hours, one vector is there. I'm going to make that hours. Okay, I'm going to clear here also. Control L, it get clear. So hours I'm going to make. So I got hours and pass. Okay, so what is that meaning? So number of hours studied, it will give whether it is pass or not. So here pass, you can see it is a categorical variable. It is having only 0 and 1. Okay. Now I'm going to make a data frame of hours and pass. Okay. So I made. So suppose if you want to know what is in the D, just select D and control enter. You can see it here. You can see hours and pass. Okay. So suppose someone has studied 0 hours, pass is 0. So 0 means fail and 1 means pass. Okay. So now I'm going to make a model. Okay, generalized linear model. Okay, so formula, we have to give a formula and then family and then data. For formula is pass versus hours. Okay, so I am going to type. So I have made a, before we were doing linear model. Now here we are doing a logistic regression. So it is the function name is GLM. So let us see what is in that M. Okay, so when we call M, it tells intercept and the coefficient of the hours, and then some residual deviance everything is there. I'll tell about in the summary. So see, there is 1 star. Okay, so some significance is there for the variables. Okay, so let us try to plot the graph. Okay, so here I am plotting hours and pass. Okay, hours and pass I am plotting. So here I got some 0 and 1s. Okay, so 0 means fail and 1 means pass. Okay, so and then these are the usual things to call the coefficients and all. So now see, this is the thing I want to tell you. Predicting. Okay, so here I am not using the predicting, I am not using the predict function. Without that, I am directly calling the equation. I told you equation. What was the equation I told you? E raised to y by 1 plus e raised to y. Okay, so here this is e exponent, e raised to, this is y. So y, what will be the, I told you what is y, beta 0 plus beta into hours. Okay, so here this is the intercept. Here you can just type coefficient of m. So this is the first one, COE, coefficient of m, first one, that is the intercept, plus hours into second coefficient. Okay, so y by 1 plus, I mean e raised to y by 1 plus e raised to y. So this is e raised to y. Okay, this is e raised to y. Okay, and then 1 plus e raised to y. So this is the, I showed you that e raised to y by here e raised to y by p equal to, I told you before, p equal to e raised to y by 1 plus e raised to y. Some books they are telling it is this is same as 1 by 1 plus e raised to minus y. Okay, you can just cross verify, because when you substitute e raised to y equal to 1 by e raised to minus y, you will get same equation. This equation and this equation are same. Okay, e raised to y by 1 plus e raised to y equal to the same as 1 by 1 plus e raised to minus y. Instead of putting this equation, some are putting this equation. Both are same. Okay, so you got this p equal to this one, p equal to e raised to y by 1 plus e raised to y. Okay, so from this equation also you will get that. If you substitute for p, if you solve for p, you will get the same thing. Okay, e raised to y by 1 plus e raised to y. So this is what here. So this is e raised to y, e raised to y by 1 plus e raised to y. Okay, so I'm going to find the prediction using that directly from the formula, not using the function. Okay, so I found the, it is stored in the variable PRED. So now let me see what is in the PRED. Okay, so it has got some this is, as you can see, everything is between 0 and 1. So naturally it has to be p value. Okay, it is a p value. I told you the p equal to e raised to y by 1 plus e raised to y. okay, from the, and now I'm going to add this line to the figure. So this is, it is called sigmoidal, okay, the binomial distribution. So a sigmoidal curve is going, and then suppose you want to see here 0.98. I'm going, so what is that, 5.50 is the last one, so I'm going to substitute 5.50 here, e raised to y by 1 plus e raised to y. So I'm going to put here 5.50 instead of hours. I'm going directly, I'm going to let me see what I'll get here. Okay, I got 0.98, so same thing, 0.985788, same thing. Okay, this is they're rounding the figures. So this is how you are getting this thing. So now I will show you how the prediction actually. So I'm going to make, so what is PRAD? PRAD is having some p values. So I'm going to make a data frame from that. This is the command for that. So now you can see what is in the data frame. So this has become a data frame. You can see it has become a data frame. Okay, I made that these values. I have made this one into a data frame. Okay, so let us see that. So now what I'm going to do is that I'm going to find in the PRAD. Okay, PRAD is this one. Okay, this is a PRAD. I'm going to find whatever, this is a mutate command, is for combining columns or variables. Okay, this mutate, you can see the help. So what I'm going to do is that from this data frame, so I made a data frame here. I'm going to, you have to load the library to get this function. Library. Okay, you have to, then only it will work. This for pushing the data. Okay, so I'm going to write whenever it is greater than 0.5, I'll write pass, and whenever it is less than 0.5, I'll write fail. Okay, so I'm taking the PRAD. So PRAD is this one. This is a PRAD. From that, I'm using if else. So whenever PRAD is greater than 0.5, I'll write pass, otherwise I'll write fail. Okay, so now let me see what is in that. Okay, see, I just made this. Okay, so whenever the value is less than 0.5, I wrote fail. Okay, now I'm going to make a confusion matrix. Okay, I'll tell you about the confusion matrix. For that, again, same thing, if else, I'm going to store that into a variable. What is that? You can just see here. Same, I made 0. Okay, if it is greater than 0.5, I put 1, otherwise it is 0. Okay, and then I'm going to make a table for, you can see here, I'm going to make a table predicted equal to this one here, this one, and the actual is what was given in the our data frame, actual data frame. So before that, I will just show you, I'm just combining the this one what I have made, and then our original data frame, and I will just execute this one. So here you can see this is an important thing. You can see here, this was our original one, hours and pass. So here it is correct, 0. We have also predicted it as fail, but see here original our data frame had this as pass, but we predicted it as fail. Okay, and here also one is there, but we have predicted it as fail, and original had 0, but we predicted it as pass. So okay, this is what we are going to do now. We are going to check it now. So I'm going to make a tab 1, a table that has predicted equal to this one, and then actual. Okay, I'm going to execute that, and you just, so this is known as a confusion matrix. So So this is actual 0 and 1, predicted 0 and 1. So when 0 and 0, that means actually it is 0 and we predicted 0. That is correct. Okay. Here this 2 means actually it was 1, but we predicted it as 0. Two numbers are there. And then 1 and 1 is 8 are there. Okay. And actually it was failed, but we predicted as pass. So two numbers are there. So the total will be our total size of this thing. So this is how this is known as a confusion matrix. So I hope you understood a little. I'll just a recap of this. So here on the main thing is how you find the P. So P is found from e raised to y by 1 plus e raised to y. Okay, and then you do some more equation, and then you find log of p by 1 minus p equal to y. The general principle here is if the p is 0.5, it will become 0. So whenever p is less than 0.5, you will get a negative value. Whenever p is greater than 0.5, this log value will become positive. Okay, so this is the principle we'll be using, and then we'll be substituting this value in our model, and then we'll see how it can be done. Okay, here we made a data frame, and then we made a model, and we took the coefficients from that model, and then we substituted that in our equation directly. Here the main thing is we didn't use the formula predict. I'll show you that how to use the formula and then do. Here we directly put that values from the model into our p equal to e raised to y by 1 plus e raised to y, and then we try to check whether what we predicted is correct or how much the prediction. So here it's a good, I mean 9 became good, 9 only 2 went wrong. Okay, 9 became correct and 8 here. Okay, so diagonal. Okay, 9 and 8 are became very correct. So that I showed you from here. So this is what I could explain to you. So what is the thing? I'll just recap here. So this is the hours and pass what we had. Okay, we made it into a data frame, and then we made a model. Okay, GLM, generalized linear model. Okay, and then from that we got our intercept and coefficient of hours we got, and we used that, and this some statistical significance is the 1 star is there, and then I plotted, and then I put that equations here. Okay, and I predicted PRED, that I predicted that p values using the equation e raised to y by 1 plus e raised to y, and I showed you how you can substitute on particular value and get the same thing. And then I made a data frame from that PRED, and then I tried to put whenever p value is less than 0.5, I put it as fail, and otherwise I put it as pass. And this I combined our predicted one and the original data frame, and I showed you this. You can see some variations are there. That variations are shown in this confusion matrix. Okay, I hope it is clear to you. If anything, just comment, I'll reply.